Hello. Before we start, let's do a sound check, because I have quite a lot of sound in my presentation, and you tell me how the volume is.
Sound check.
More? A little bit more?
No, good. Sound check.
No, too much.
A little bit lower.
Sound check.
Perfect. A little bit lower.
Sound check.
Perfect. Okay, let's go. We are going to talk about accessibility. Are you excited to learn more about accessibility? That wasn't very excited. A little bit more excitement. Yeah, that's nice. I'm the last person between you and lunch, so let's get started. So accessibility is all about ensuring equal access for people with disabilities. And you are likely familiar with accessibility features in the public space, such as curb cuts, ramps, elevators, sliding doors. They all help to remove barriers for people with disabilities. But similarly to how curbs can be challenging for somebody using a wheelchair, some of the features in our digital products can create barriers for somebody using assistive technology, like a screen reader, a voice control, a switch device, or a braille keyboard. In this talk, I will cover some basics of accessibility on the web, but also will explore several examples in React applications that help us avoid creating such accessibility bottlenecks in our products. We've got quite a lot to cover, so let's start. And I want to start with some foundations. This will help us to understand all of the examples we'll go through next a lot deeper. So on the web, everything starts with HTML. It describes our page's structure and its contents. It gets parsed by the browser and is transformed into a DOM tree, out of which browser builds visual UI that you can see and interact with. However, it doesn't end there. In parallel to this process, browser also builds an accessibility tree, which contains all important accessibility information about elements on the page. Then this tree is exposed to assistive technology and is used to navigate the page. But it's a lot easier to understand when looking at the example. For this HTML page, accessibility tree will look something like this. Note that not only all the elements are included, only the ones that have some semantic meaning are exposed in the accessibility tree. And this div that we use for styling, for example, is omitted. Each element in the accessibility tree has its role that defines what kind of element it is, what is its purpose, and an accessible name, which identifies it on the page. Additionally, it can contain a lot of other attributes that describe it further or communicate its current state. You actually can see all of this information in your DevTools. There is accessibility tab, and you can explore all of the accessibility properties in there, or you can even turn on full-page accessibility tree and see the whole tree together. It is super useful for debugging. Now this tree is exposed to assistive technology by the browser and will be used to navigate the page. Let's see what that might look like.
Page with content. Heading level 1. Hello. Waving hand. Image. Main. Let's learn about accessibility. Start button.
As you can see, or rather hear, in this case, screen reader announces information straight from the accessibility tree. It uses all of those accessible role and name to describe elements on the page. And while in this example, I navigated the page sequentially, screen reader users have a lot of shortcuts to jump by headings, interactive elements, landmarks, links, and so on. And this is exactly why using semantic HTML is so important. Using semantic elements, we can convey meaning behind our code, and therefore make it much easier to interact with. And there are over 100 different HTML elements that we can use, all coming with built-in semantic roles, states, and other attributes. And by using them, we can get a lot of built-in behaviors for free, but also make our code more meaningful and accessible. However, for modern UIs, what is built in HTML might not be enough. And we want to create some patterns that aren't supported in HTML yet. And this is where ARIA comes in. You've probably seen some of those ARIA dash properties in HTML. ARIA stands for Accessible Rich Internet Applications. And there's a spec that defines a set of HTML attributes that give us more granular control over accessibility tree. For example, we can override the role using ARIA role attribute. However, it is important to note that ARIA just provides the semantics. It doesn't change behavior or appearance in any way. So if we were, let's say, to set a role of a button to the div, yes, it will be updated within the accessibility tree, but it won't make an actual pressable and focusable button out of this div. To do that, we would need to implement all of this functionality ourselves using CSS and JavaScript. And as you can see, it actually takes quite a lot to build a simple button. However, so in most cases, it's much easier and will be more accessible to use native HTML instead. It is even noted as the first rule of ARIA inside the spec. So essentially, the spec says, don't use ARIA unless you absolutely have to. And while we shouldn't re-implement buttons with ARIA, it is really useful for implementing patterns that don't exist in native HTML, like tooltips, tabs, switches, combo boxes, and so on. Additionally to roles, we can also set different states and other properties using ARIA. They're all prefixed with ARIA-something. In a way, using ARIA is like performing precision surgery over accessibility tree. It gives us as developers a lot of power to modify different properties. However, with a lot of power often comes a lot of responsibility. And the research shows that pages that use ARIA actually have more accessibility errors than pages without. Which just shows that with this amount of control, it's quite easy to mess things up. So we need to make sure that we use it only where necessary, and we are really responsible when doing that. So now we've talked a little bit more about how accessibility works on the web. We talked about semantic HTML, accessibility tree, and ARIA, and we are ready to dive into some of the examples I wanted to cover. And the first is quite simple. Let's talk about icon buttons. If you have a button with an icon usually serves a purely decorative purpose if there is a label in there. However, icon itself would actually be announced by the screen reader, which is not necessary and can actually sound confusing. So in many cases, we might want to hide icon so that it wouldn't be announced. For that, we can use an ARIA attribute called ARIA hidden. Essentially, it will exclude this element from the accessibility tree. But often in modern UIs, we have buttons without any labels at all, with only icon to communicate its purpose. It helps to fit more actions on the screen. However, in this case, there wouldn't be any accessible name on this button that can be used to announce it to the user. So it will be announced like this.
Button.
Imagine having 30 of those on the screen. You wouldn't be able to tell which one is which. We can use ARIA label attributes that will override the accessible name within the accessibility tree. However, it has some limitations. In most browsers, for example, it wouldn't get translated if the translation feature is on. So there is a better way. We can remember the first rule of ARIA use and try not to use ARIA in here. So what we can do is that we can display an actual label within the button, but hide it from the visual UI. A lot of our usual hiding techniques, like display none, will actually exclude it from the accessibility tree as well. So instead, we need something different. There's this visually hidden snippet that we can use, which essentially just shrinks this element and hides it out of the viewport. It is a very common technique for accessibility purposes and helps us create content that is only accessible for screen readers, but it's hidden visually. And this is, in the case, our button label will be announced properly like this.
Edit post, button.
It is a very common pattern, so I would suggest to extract it into a separate component. We can call it visually hidden and use in any cases we need. Now, by implementing icon buttons, we learned how to hide stuff, how to hide purely decorative elements using ARIA hidden attributes, and how to hide elements from visual UI using visually hidden technique. However, there is another important consideration when using interactive elements, and it is focus. So let's briefly talk about it. So by default, browsers provide a focus outline for all interactive elements on the page to indicate which one is operable with the keyboard right now. However, often when these don't match the aesthetics of the design, they're either completely removed or replaced with something that's barely distinguishable, which makes experience for keyboard users really confusing. Imagine trying to use the page without seeing your mouse pointer on the screen. So instead, we can actually create beautiful and legible focus outlines to match our design language. In my case, it's pink to give it something little extra. But with focus outline, we also have this challenge that is actually displayed when using the mouse as well. But now we also have focus visible pseudoclass that is well supported across modern browsers, and it makes sure that focus indication is displayed only when navigated via keyboard and not the mouse, which kind of lets us achieve best of both worlds. We are not getting the outline when using the mouse, but it is very functional and legible for anybody using the keyboard. Now let's have a brief look on a little bit more complicated focus management scenario. A common pattern is to display a set of actions on hover that then we can use. Usually we'd implement it with setting it absolutely positioned and setting opacity, then changing this opacity to 1 when we are hovering on the parent element. In this case, it is card. But there's a problem here. Now, if you would try and navigate via keyboard, we wouldn't see our elements in focus. They're actually there, but we cannot see elements that are currently being focused. So ideally, we would like to show these actions when they are focused as well as when the card is hovered. We could do it with focus within a pseudo class, which will basically display it if anything inside this element has focus, but it will actually worsen experience for mouse users as well. So now if I go with the mouse, you can see that even though I left the card already, the actions are still displayed, which can look quite glitchy in the UI. So sadly, we don't have focus visible within pseudo class, but there's a different way. We can use head selector in CSS. It's actually kind of amazing. It's one of my favorite newer features in CSS, and it allows us to target parent based on its children. So what we are saying here is that if in our actions we have any child with focus visible, then we shouldn't apply opacity. And this works. It gives seamless experience for mouse users while also making sure anybody using the keyboard is not left behind. But generally, to go a little bit extra mile, we can think about other interactions as well, such as touch, where our actions won't be accessible. To fix this, we can do really easy change. We can just wrap all of our styles with a media query, hover, which will match if any connected input device supports hover interaction. And then we can provide a fallback when this interaction is not supported and display our actions differently. So we kind of learned right now how to create legible and functional focus indicators, but also how to manage focus for hidden actions. And I'd love to move to the next example, which is implementing accessible text inputs. Inputs need labels. They need something to identify them on the page. Because imagine filling a form like this. It seems confusing, right? Unfortunately, this is experience for a lot of people using assistive technology. So it is important that the way we label our inputs is accessible to them. We have HTML label element that we can use, and when positioned near the input visually, it will already convey the information. But if we listen to the screen reader,
edit text, blank,
you can see that it doesn't pick it up. It happens because the label is not recognized, it is not related to the input in any way. To fix this, we need to explicitly connect label element to the input element using foreign ID attributes. Now, contents of the label will be used as an accessible name for the input and will be announced properly to the user like this.
Username, edit text.
We can also bind our label implicitly by wrapping label element around the input. But generally, this method is less supported in different versions of screen readers. So if you're using this, still binding explicitly is preferred. However, in modern UIs, sometimes we don't have any visual labels, and we rely on some other elements to communicate meaning of this input. So let's briefly look how we can implement label-less inputs. So we usually visually use a placeholder to communicate kind of purpose of the input in some of those cases. However, placeholders generally have quite low support in assistive technology. And while we could use ARIA label here again, I want to show you a better way. We can take our visually hidden component from before and modify it a little bit better. So currently, it always renders a span, which is quite limiting. We can add ability for it to preserve semantics, what is known as polymorphism. So we can provide with an as attribute a semantic element we want our visually hidden to be rendered as, which would allow us to render it as label in this case or as any other element. And it's generally a super useful technique in design system to make sure you are able to control semantic elements under your design system components. And now we have a visually hidden label in here, and we can use some other means to communicate, for example, an icon, or based on the context for the users, but we'll still have label in there. And generally, with labels, we want to keep them clear and concise. But sometimes we need to provide some additional information to the users, different instructions or hints like this. To implement this, we can just place the text underneath the input and style it accordingly. But again, because it is not connected to the input, it might be overlooked by the screen readers. Also, some screen readers have what is known as form mode, meaning as soon as they enter a form, they kind of start ignoring all non-interactive elements. So some of these text notes might not be accessible at all. To fix this, we can use another ARIA attribute called ARIA described by, which will allow us to set accessible description, which is empty by default. We can set it using ARIA described by attribute, and then set an ID on our span and connect it together. Now, contents of the span will be used as an accessible description for our input. Descriptions are typically announced after a pause, like this.
Edit text. Must be between 3 and 20 characters long.
As you have noticed, we kind of often use IDs in order to tie different elements together for accessibility purposes. But because IDs need to be unique, and naming things is kind of hard, in React, there's this super useful tool called useID that you can use that will generate a unique ID for you that you can use for accessibility purposes. Like here, we can generate ID for our input and then use it to bind different elements together so that we wouldn't need to come up with unique names. Now we've talked about labels and providing hits to our input. I think it's useful to talk about validation as well, because the way that we guide the user through the form and communicate errors can have tremendous impact on the user experience. We generally have often a combination of required and optional fields, and it's useful to communicate to the user which is which. Visually, we often use this red asterisk symbol to indicate that something is required. So let's see how we can implement this. We can add an asterisk to our label, but if we navigate it to the screen reader, we can actually see it pronounced like this.
Username star, edit text.
Which is less than ideal. So it is a similar situation as we had with an icon before. And we can, again, employ ARIA hidden attribute in here to hide it from the accessibility tree. Now we have the visual cue. We have this asterisk symbol. But we still need to tell in some way to assistive technology that this input is required. We can use HTML required attributes, but it will also introduce HTML default validation, which is not something that we always want. In some cases, to have more control over the user experience, we might want to implement our own validation instead. So we kind of need to have a semantic cue, but not associated behavior, which is the really good use case for ARIA. We can set an ARIA required attribute instead, which will provide semantics, but it wouldn't impact the behavior in any way. And then it will be announced to the user like this.
Username, required edit text.
And while generally marking required fields is a really common approach, you might also want to consider marking optional fields instead. In this case, form can be visually perceived as less threatening, but if you do it, I would still recommend leaving ARIA required attribute on, so that, because screen users cannot see the whole form at once, but it will help them to understand which inputs are required when entering them. Now that we've turned off our default validation in the form, let's see how we can implement our own validation that would be accessible. We can display an error message underneath the input to communicate that something is wrong. But also note here that I'm displaying an additional icon. It can help for colorblind people to distinguish errors so that we wouldn't rely only on color to communicate this information. Now, as we have the visual cue with our red border and an icon, we need to provide a semantic cue as well. There's another ARIA attribute we can use called ARIA invalid, which will then communicate it to the user. One handy tip in here is that we can actually use all of the ARIA attributes for styling purposes as well. I really like this approach because I don't need to write an additional CSS class, but also it is more reliable because it makes sure that my visual cues, like red border and an icon, and my semantic cues are always in sync. Now that we've marked our input as invalid, we also need to communicate an error message as well. We can use here the same approach as we did with the accessible description. So we can just connect our error text to the input using ARIA described by attribute. And actually, if you needed to have several elements connected, you can provide several IDs in there, and then they will be concatenated together when announced to the user. Now, when somebody enters our input, the error message will be communicated properly, like this.
Username, invalid data, edit text. This username is taken.
When talking about inputs, we learned how to use ARIA to set accessible descriptions, to expose validation errors, and required and optional fields. Now, the last example I want to cover, and in my opinion, is the most interesting one, is how to implement accessible notifications. Notifications in visual medium come naturally, right? We just display a message on the screen, and the more important the message is, the more visually prominent it becomes. Because you immediately see the whole screen, you're able to immediately notice it and react to it. However, Screen Reader works sequentially, and often our notifications can be in a completely different place from where Screen Reader is focused right now. So we need a different way of notifying users of assistive technology. And this brings me to another really powerful feature of ARIA called live regions. It allows us to define certain places within the page as live. And then these areas will be watched. And if something changes in there, no matter where Screen Reader is positioned right now, it will be notified and can announce this change to the user. We can set ARIA live regions with ARIA live attribute, which supports several settings. It's off by default. It can also be polite, meaning that it will wait for current speech to finish before announcing the change. Or it can be assertive, meaning that it will interrupt the speech for the announcement. To implement the notification, we can set ARIA live attribute on our message that will turn it into a live region that will be observed. A better way would be even to use a role. There's a role status that will, under the hood, set ARIA live to polite for us, along with other useful attributes, for example, ARIA atomic, which will make sure that the whole message always gets announced, even only part of it changes. Now, Screen Reader user can be notified like this.
Delete button. Item was deleted.
We can use the same approach for communicating errors as well, like here. In that case, we can set ARIA live to assertive on our element containing the error message, or we can set role alert, which will do the same under the hood. Now our error will be communicated.
Sign in button. Sign in failed. Username or password are incorrect.
Now our error will be communicated to the user like this. So we can also use the same approach for input validation. If you want to provide instant feedback as user inputs data into the field, we can implement it by setting another kind of role alert on our error message from before. Then when it changes, it will be immediately announced to the user. Let's look at how some of these things work together in a little demo.
Username, required edit text, R. Username is too short. H. This username is taken. 2. Username is available. Email address, required many pop-up edit text email. Display name, required many pop-up edit text. Kateryna Porshnieva, window. Website, edit text URL. About you, edit text. Sign up, button. Sign up failed. Email field is invalid. About you, website, Kateryna Porshnieva, email address, k.porshnieva@gmail.com, window. About you, sign up, button. Account created. Check your email for confirmation.
It's great, right? So you can see that all of our elements are properly announced, errors are communicated, statuses are communicated, and you can clearly navigate through the form, which resulted in a smooth experience filling this form using only the Screen Reader. If you haven't ever used the Screen Reader yourselves, I really encourage you to do so. I know that can be intimidating at first, but there's, for example, VoiceOver comes built in on macOS and iOS. There's NVDA and JAWS that you can install on Windows, and there's TalkBack on Android. The first experience using Screen Reader can be quite confusing. So if you haven't tried before, I really recommend this video series on YouTube from Rob Dodson from Chrome team that covers quick guides on different screen readers. And then to help you to get started. However, naturally, you as developer would use screen reader quite differently from an actual person with disability. So if you have an opportunity to engage with people with disabilities to use your product, I really recommend you do so. It's something we did quite a lot of Buffer, and it resulted in a really eye-opening experience for all of engineers and building a lot of empathy and making accessibility a bigger part of our work. If you don't have ability to do that, there's also services like Fable that connect you to people with disabilities. And they can provide feedback, accessibility feedback on what needs improvement in your product. As the last thing I want to note that accessibility is not black and white. And by learning more and continuing to make small improvements, we can move towards a more accessible and inclusive web for everyone. There's only so much you can cover in 30 minutes, so you can follow this QR code if you want to learn more. There's more details about testing accessibility, links to different tools, and references to dive deeper into these topics. And thank you for listening, and I hope you're now more excited about accessibility.